In this video, I'll walk you through a simple example explaining how you can perform feature selection using the chi-square test. So let's start by importing the necessary modules. I have a file called as accident.xlx which I'll load into a data frame called df, and this is how my data frame looks like. I have three columns. First two columns are my features. The final column, which is my accident column, is my target variable. Before we move forward, one assumption before you go through the entire video is you are well aware of the theory behind a chi-square test. What a chi-square test is, how is it defined, what is the null hypothesis, what is the alternate hypothesis, what type of data it is suitable for. If this idea is not clear, drop in a comment in the comment section so that I can create a video on that. However, there are already a lot of videos available on YouTube, so you can refer to those videos and come back to watch this video again. If that idea is clear, then we can move forward. The first thing that we'll do is we'll find out if there is any pattern that we find with respect to a feature column as well as the target column. So I create a simple crosstab between the is adult column and the accident column. As you can clearly see, is adult column has only one value, which is 1. So the data that was captured had only adult values in it. So there is no deviation in the data set whatsoever. So all the values in this column, which is adult column, come out to be 1. So there is no significant pattern based on changes of if the person is not an adult, is he prone to accident or not. There is no such pattern in this feature and target variable combination. Now that we've looked at the first feature and target column combination, let's now move to the next feature and target combination. So my next feature was gender, which is denoted by the column is underscore male, and I have my target column which is called as accident. Now if I plot a crosstab, this is what I observe. In total, the survey was carried out for 927 people, out of which I had 726 male people and 201 were females. And as I can see clearly, there are a lot of people in the male categories, that is around 99 people, who are prone to accidents as well. So there is a clear pattern that I can see based on gender as well as based on their accident prone capability. So now using chi-square test, based on the two features that I have, that is gender and age, am I able to figure out if something is a valid feature or not using a chi-square test. Let me also mention that my features as well as my target columns are discrete in nature. So the values are only 0 and 1. Chi-square test works essentially on categorical variables or discrete variables in short. So if you use continuous variables, the whole purpose of using chi-square test goes for a toss. So that is why I wanted this assumption to be clear, that where you use chi-square test and so on and so forth. Now, if the whole idea of what we have done so far is clear, so let's move on and see how the chi-square test can be utilized for feature selection, but we'll go one step at a time. So firstly, we'll visualize the chi-square results of one feature and one target column and see how it is implemented inside select k-best function for feature selection. So I've created a simple function called as check underscore categorical underscore dependency, which accepts the crosstab table that I've created for the two combinations of feature and target columns, and a confidence interval value that I want to validate my hypothesis against. The way the function is defined is I use the stats API, which has the function chi2 underscore contingency, which accepts the crosstab table, and it returns me the statistic value, which is the chi-square statistic value, the p-value, the degrees of freedom, and the expected table. So in chi-square, if you know the theory, you have an expected table as well as an observed table, and your chi-square value is compared between observed and expected values. So this is what expected would return. Expected would return a table which is of the expected values for a given combination of categories that you're considering. I also print out my chi-square statistic value as well as the p-value. I find out the alpha value, which is 1 minus the confidence interval that I've defined in my function definition. If my p-value is less than equal to alpha value, then I reject my null hypothesis and I say that both the feature and target column are dependent in nature. If my p-value is greater than my alpha value, then I fail to reject my null hypothesis and I say that both my feature and target column are independent in nature. Again, keeping in mind both the feature and target columns are categorical or discrete in nature. So I run this cell to load the function in RAM or memory. I pass in my first crosstab table, which is adult underscore accident underscore crosstab, which is basically this table. I pass this table into this function and I want to check my hypothesis for a 95% confidence interval. So I run the cell and this is the output that I get. My chi-square statistic value is 0 because my observed and expected value table, if you see this table, this is the expected table and my observed table are the same. My p-value is 1, that means it's greater than my alpha value which was set to 0.05. So both my feature and target column are independent in nature, which was very evident. There was no pattern in my data for the column is adult because all the values that were captured were for adults. I walk through the same exercise for the second table that I have, which is gender underscore accident underscore crosstab, and this is what I observe. I get a chi-square statistic value of 11.27 with a p-value of 0.02. Since my p-value is less than 0.05, I reject my null hypothesis. So I conclude that my target column, which is prone to accident, is dependent on my gender column based on the p-value that I'm getting using the chi-square test. And if I plot the expected value, this table is slightly different compared to your overall table for the gender column. So this is the gender column crosstab table and this is the expected value table which is calculated using the chi-square test. So based on the cell-to-cell difference of observed and expected, you calculate the chi-square statistic value, which in our case turned out to be 11.27. If this idea is clear, let's move on to feature selection using select k-best, which has an option of chi-square as a technique of filtering out features which are of less relevance. So first I separate out my features into the x variable and I separate out my target variable, which is accident, into y variable. Now I call the select k-best function wherein I pass that I want just one feature which has the highest chi-square value and I transform that xy combination based on the chi-square test statistic and save it into a new variable called as x underscore new. I run the cell and when I plot the shape of the cell, this is what I observe. I have a total of 1 column and 927 rows. And if I do a crosstab of the new column that I have generated using select k-best, I observe that this is the same as the observed value for is male column. So 154.47 is the same as 154.47. So under the hood, what select k-best is doing is takes in one feature, takes in the target column, calculates the test statistic value, calculates the p-value and stores it into a list. And it keeps appending this list based on a feature, target, chi-square calculation that is there. Once this list is populated by all the combinations of feature and target column for a given data set, it sorts it based on the ascending order for p-values and keeps only those features that you have specified in the k variable. So if I have 10 features, I have the p-values of 10 features with respect to the target column for a chi-square test. I sort it in the ascending order. If I want just the first 4 features having the maximum relationship or dependency with my target column, I will store that into my overall feature transformed column. So that is how select k-best under the hood using a chi-square method finds out the relevant features for a given target variable. So I hope you found this video informative. If you do have any questions with what we covered in this video, then feel free to ask in the comment section below and I'll do my best to answer those. If you enjoy these tutorials and would like to support them, then the easiest way is to simply like the video and give it a thumbs up. And also it's a huge help to share these videos with anyone whom you think would find them useful. Please consider clicking the subscribe button to be notified for future videos. And thank you so very much for watching the video.